Have you ever seen the calculated data type in an Access table and thought to yourself, hey, that looks handy? Well, it can be handy, but it can also paint you into a corner later. Welcome to another Tech Help Quick Queries video brought to you by Access Learning Zone. I'm your instructor, Richard Rost. Today we're going to talk about the calculated fields in Microsoft Access tables, why I generally recommend putting your calculations in queries instead, and my thoughts on that subject. In addition to that, we've got answers to questions from YouTube comments, my forums, emails, and lots of other stuff. All right, let's get to it. Today's first question comes from Diego in Newark, New Jersey, one of my Platinum members. Diego says, I'm building an order database and noticed Access lets me create a field that automatically calculates an extended price from quantity and unit price. I've heard you say that you don't recommend calculated fields in tables and even call them evil. Are they actually bad, and when would it be okay to use one? Well, yeah, Diego's talking about my evil Access Tough page, and on here I do have, where are they? Yeah, right there. Calculated fields in tables. Use calculated query fields instead. Tables shouldn't contain calculations. That's my opinion, and I'm sticking to it. Let's talk about why. Now, calling them evil is a little dramatic, of course, but it's the dramatic stuff that tends to stick in my students' brains. Now, Access isn't going to burst into flames because you put a formula in a table. But it's still a good question because Access does let you create a field with the calculated data type right in the table. You give Access a formula and it automatically works out the result for every record. For example, if an order detail record has quantity and unit price, you could add an extended price calculated field with a formula like quantity times unit price right in the table design. Now that sounds handy, and sometimes it is, but just because Access lets you put a calculation in a table doesn't necessarily mean that's the best place for it. Now my general philosophy is very simple. Tables are for storing data. Queries are for calculating, filtering, sorting, and combining that data. Now, let's all make sure we're on the same page here. A calculated table field is a field whose data type is literally calculated. Instead of entering a normal value into that field, you provide an expression, which is just Access speak for a formula. So in the order detail table, you might have quantity, unit price, and extended price. And those are all fields in the table. And the extended price expression could be quantity multiplied by unit price. All right, customer buys 3 widgets at $10 a piece. Access shows $30 in the extended price field. Change quantity to 4, Access gives you 40. Nobody is supposed to type directly into the extended price field because it's the answer, not the input. And that's the basic appeal of calculated table fields. The issue isn't that this calculation is wrong. The issue is whether the table is the right place to permanently define that calculation for your whole application. So why do I put these on my evil Access stuff list? Well, evil is my fun little shorthand for Access lets you do this, but there's usually a better way. It's not illegal, right? The Access police aren't going to show up at your house. Well, at least not for this. But the real concern is database design. A table is the foundation of your database. It should primarily describe the facts you're storing. What was ordered, when it was ordered, how many were ordered, what the price was. The calculation is application logic. It's a rule for turning those facts into an answer. Queries are designed to do exactly that kind of work. When you keep the calculations in queries, you can change the calculation, make another version of it, use it in a report, combine it with other tables, right, without changing the underlying table design. So calculated fields aren't automatically bad. They're simply more restrictive than many beginners realize. The biggest limitation that calculated table fields have is that they only work with fields from that same table. Our quantity times unit price example works because both pieces of information are right there in the order detail table. Nice and simple. But real-world calculations often don't stay simple for very long. Maybe the sales tax rate depends on the customer's state. Maybe the current price comes from the product table. Maybe a discount comes from a pricing table based on the customer's membership level, right? Maybe a commission depends on the salesperson and the product category. So now you can see how you start to deal with information stored in different related tables, which is exactly what a relational database is supposed to do. Now a query can bring together customer T, order detail T, product T, perhaps a tax rate T, right? Bring them all together in a query. And then the query can calculate the value using all of that information. A calculated table field in the order detail table can't reach across the database like that. It's stuck in its own little room, right? Queries have the keys to the whole building. Even when your calculation starts out simple, it might grow later. Today, extended price might just be quantity times unit price. Tomorrow, you might need a report that includes a discount. Next month, you might need a different version that includes tax. And then your accounting wants the pre-tax amount. And then sales wants the customer-facing total. And then if the formula lives in the table, you've got one table-level calculation trying to serve every possible purpose. And that can get difficult fast. With queries, you can make an order detail query for your standard calculations. Then you can make an invoice query that adds tax and shipping. You can make a sales commission query that calculates commission, right? So every query can each provide the answer needed for that job. And you can also use the query as the record source for multiple forms and reports. That way, the report gets its data from this query, and this other form gets its data from that table, and blah, 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 right? And as your calculations become more sophisticated, queries generally give you more room to work with the functions and expressions than calculated table fields do. And if I know I'm probably going to end up putting something in a query anyways, I just prefer to start there in the first place. Another common misconception is that putting the calculation in the table makes the database faster. Not necessarily. A calculated table field is not the same as pre-computing a value and saving that result as ordinary data. And calculated table fields can't be indexed, so they don't give you an automatic performance magic wand. For everyday calculations like quantity times price, the difference normally isn't worth worrying about in a typical Access database. Just let the query calculate it. Now, there are absolutely situations where storing a calculated result in a normal table field makes sense. Maybe you've got a very expensive aggregate calculation over, a huge amount of data, or maybe the database has far more reads than writes, or maybe you just have to preserve, exact historical values at the time of the transaction. But that's a separate design decision. In that case, you're saying, I want to calculate this value and save it, right? You're not saying, I want an Access calculated data type. So don't confuse those two tools. They solve different problems. A calculated table field shouldn't be treated as a performance feature. For simple calculations like quantity times unit price, I'd use a query. A query provides the same result while keeping the calculation separate from the table. Now, one example of when it's good to store a value is suppose you've got hundreds or thousands of order records and you're constantly displaying monthly sales totals, right? You could calculate that every single time by adding up all the orders for that month. But if those older months aren't changing anymore, you might calculate the total once and store it in a regular field, right? Call it like monthly sales total. Now Access can just read that one value instead of adding up thousands of records every time. All right, that's called denormalization. And I've actually got a whole separate video on when you want to do that. I'll give you a link in just a minute. And sometimes we do denormalize our tables deliberately for performance, but that's still a normal data field. It's a normal stored field. It's not the calculated data type that we're talking about here. Now, whenever I do one of these videos, I always do some research, and I have seen some reports. I haven't verified this myself, but I have seen some reports that when you're dealing with millions of records, you may see a slight improvement in performance using calculated table fields. But my opinion is, if you've got a database with millions of records, you probably should be using SQL Server anyways, and then that becomes moot. So Performance can be a minor legitimate reason to consider a calculated table field, but as always, I would test it with your actual data after making a complete backup, of course. Another consideration is portability. Calculated table fields are an access-specific feature. So if your little access database stays a little access database forever, that might be just fine. But as I've seen over the past 30 years, databases grow. Even databases that you didn't think would grow, when your company grows, it's going to grow, right? Maybe several people start using it. Maybe you move the tables to SQL Server. Maybe you hire another developer who's got to work with it, and he looks at you like, what is this mess? I've been that developer. I've gone into companies before, and I'm like, who did this? I got to be very careful, though, because the guy I'm talking to might be the guy that did that. So you have to tread lightly in that case, right? But maybe you'll upgrade. Maybe you'll build a web application around it. Who knows? And when that happens, you can't assume that an access calculated field will nicely move over and behave in the new system, right? It might need to be rebuilt as a query, a view, an application code, something else, right? Now, don't over-engineer a database for a future that might never happen. If you're tracking your baseball card collection at home, SQL Server migration probably isn't your number one worry. But keeping tables focused on stored facts and putting calculations in queries is usually a cleaner, more portable habit from the beginning, right? So don't lose sleep over thinking about migrating your database in the future, but learn some of the best practices now so you don't shoot yourself in the foot. I've shot myself in the foot many times because I didn't know any better. So that's why I'm trying to teach you guys this stuff. So when's it okay? Is it ever okay to use calculated table fields? Yeah, sure. Our quantity times unit price example. If both values are in the same record, the formula is simple. No one will ever need to override the result, and that extended price is useful almost everywhere you use the table, then a calculated field could be reasonable. If you're staying entirely inside Access, you understand the limitations, go ahead. I won't send the Access police to your house. Your database probably won't explode. Probably. But the important part is that you're choosing it for a reason. Not just because the calculated option happens to be sitting there, right? And that data type list is looking tempting, right? My preference would still be to create an extended price field in a query, because it leaves me more options later. But a simple calculated table field, it's not a database crime. It's just a trade-off. And as long as you understand what you're giving up and what kind of trouble you're possibly getting into, you can make an informed decision. So, in a nutshell, calculated fields and access tables are not evil in the literal sense, right? They're not going to cause plagues of locusts and that kind of stuff. They are a legitimate feature, and they work fine in certain simple same record calculations. But my standard rule remains. Tables store data, queries perform calculations. Queries can use multiple tables, handle more sophisticated expressions, give you different calculations for different purposes, and keep your application logic separate from the raw data. And that's a big one for me. Queries also give you a cleaner path if your database grows beyond access someday. So don't be afraid of calculated table fields. Just don't use them automatically. Don't use them all the time. Start with a query unless you have a good specific reason to put that formula in the table. Trust me, it's a habit that will save you headaches later. If you want to learn more, here's a video on calculated fields and how to make them in queries and forms. You can also do them in reports. In the extended cut for that video for the members, I do go through a couple of examples of using calculated table fields. This video talks about storing a value versus calculating it on the fly. That's the discussion we had a few minutes ago, right? When is it okay to store a value in the table that could be calculated? And here's that video on denormalizing your data when this makes sense. So check these out. These are all free videos. They're on my YouTube channel. They're on my website. And yeah, they're all free. So check them out. Let's see what else we got in the mailbag today. Heading over to my website forums, we've got Amir building an employee database where one employee can report to multiple supervisors, and a supervisor can have multiple direct reports or assistants. He's got a many-to-many junction table working, but the sticking point is displaying the employee names instead of just a bunch of IDs in his supervisor and subordinate subforms. And this is a good one because the trick is realizing that both sides of the relationship point back to the same employee table. And Donald has the right approach with one junction table and two subforms, one showing who the employee reports to and one showing who reports to them. Then each subform gets a query that joins the appropriate ID back to the employee table. So you can display the person's full name. And Kevin also pointed out that, let me bring this down a little bit. If you ever need both names in one query, just add the employee table twice. And Access will call the second copy something like employee T_1 or something like that. And that's probably, let's see, that's way down. I added a bunch of stuff. Yeah, here's Kevin's other comment, right? You'll get employees _2 or whatever, or _3. And then Thomas added a bunch of stuff. He owes me 2 cents for talking about his database again, which is a pretty cool database, by the way, I do have to say. He's added a lot of stuff to this one. But, yeah, this guy came up. It's a pretty cool thread. I'll put a link to this one down below. You can read the whole thing yourself if you want to learn more. Next up, we got Raymond. He ran into a weird one. He had a subform that kept filtering itself based on the parent form, even though link master fields and link child fields were blank. The subform showed everything when opened by itself, but as soon as the parent form was bound, the records disappeared, almost like Access remembered an old link that wasn't there anymore. And this is definitely one of those Access being Access situations. Normally, if the link master and link child fields are blank, that means the subform shouldn't be filtering based on the parent. And a table relationship by itself shouldn't secretly do that either. And Raymond checked the obvious stuff, even recreating the subform control, and that didn't fix it. So at that point, I'd suggest some old design baggage or corruption. It's a database he's been working on for years. Matt had a good suggestion, and that's to use save as text so you can inspect what Access actually stored. And then I'd also try a decompile followed by a compact and repair. Since making the parent unbound fixed it, I'd call this a quirk, unless you can reproduce it consistently. So Access has a lot of those just weird behaviors. Next up, I want to just briefly go over an email that I received. I've actually gotten this from a couple of people over the last month or two. This one's from Alan in Detroit, Michigan, a former Platinum member. He said, I've really enjoyed your Access classes and I've learned a lot from them, but I've decided to cancel my membership. Lately, I've been using AI for most of the Access work I need to do. I can describe what I want, and it gives me the queries, VBA code, or steps to follow, so I don't feel like I need to spend as much time learning how to do everything myself anymore. Thanks for all the help over the years. I just wanted to let you know why I was canceling. I've actually, like I said, I've gotten a few messages like this recently, and I completely understand. I use AI all day long myself. It's an incredible productivity tool. But I wouldn't confuse AI can do this for me with I don't need to understand this anymore. I look at AI like a calculator. A calculator means you don't have to do long division by hand every day, but you still need to understand math. I always say you should treat AI like a really capable junior assistant or an intern, right? Give it work, review what it gives you, and I sometimes have to say, no, that's not how Access works. And if you don't understand Access yourself, you might not recognize when the AI gives you something that's subtly wrong, right? So I absolutely do use AI. I do. I let it write some of the code that saves me a lot of time, right? I already know how to write record set loops. So I might say, all right, I need a record set loop that goes through these, customers with this condition, and I need to do that with it. Okay. Instead of spending 20 minutes writing it myself, I can have it spit out for me in 15 seconds. So outsource some of the code writing, that's fine. But don't outsource your understanding along with the work. The people who know their subject are going to get far more out of AI because they know what to ask for and they can recognize a bad answer, right? And they know how to fix it when something doesn't work. AI is a force multiplier. It's not a replacement, right? It's garbage in, garbage out. The more you know going in, the more useful it becomes when it gives you something out. So I love AI. I use it a lot, but don't have it replace your thinking for you. Still understand what you're working with. All right, let's head over to the YouTubes. We got Kevin pointing out that you can also use the int function to chop off decimals. But there's an important difference between int and fix when you're dealing with negative numbers. And yes, I mentioned this in the video. For positive numbers, int and fix will give you the same result. But with negatives, int always rounds down. So negative 109.9 becomes negative 110. Fix chops towards 0. So 109.9 becomes 109. Negative 109.9 becomes negative 109. That's why I used fix in this video. So if you literally want to chop off the decimal portion without any rounding, fix is the better choice. And the example that I give in this video is working with like sheets of financial data. And, you know, for every debit, you've got negative numbers on there. Yeah, I want to just chop off that decimal point. I don't want to round it down. All right, next up we got John, who says, my pronunciation of the number was very American-centric because in British English, you'd normally say 15,110, whereas I said 15,110. So yeah, this is a difference between American English and British English. John's absolutely right. I had to look this one up. I was always taught in school and in college and in programming books and stuff that I've read that you don't say and inside a whole number. So in American English, you'd say 15,110 and 15 cents, right? But in British English, 15,110 is standard. So it's just one of those little differences between American and British English. You guys add an and, we throw out a U from color and armor, and somehow civilization continues. So thank you, John, for correcting me. And this is one of those things that, you know, I love learning from you guys too. I actually had to look this one up. The Cambridge British Grammar Guidance, it gives 600, let's say if you got a number like $625 and 15 cents. In American English, you'd say $625 and 15 cents. And in British, you'd say $625 and 15 cents. So John's comment is absolutely legitimate. The British are apparently much more generous with their ands than we Americans are. Next up, we got B. Jones. He says he understands my rule about storing phone numbers as text, but points out that numeric fields can also store a typical phone number just fine. And sure, you can store a phone number as a number, but my rule is about what the value represents, not what characters happen to be in it. You're never going to add two phone numbers together or calculate the average of your phone numbers, right? So there's really no benefit to making it numeric. Text will preserve leading zeros, right? That happens with things like social security numbers. Handles extensions, plus signs for international numbers. Doesn't care if the format changes later. Same thing with zip codes, account numbers, part numbers, all that stuff. If it's an identifier and you're not doing math with it, I store it as text. Text is just a lot easier to work with. Give me the left 3 characters. Give me the right 3 characters. Plus, I don't know if you're old enough to remember, but back in the day, like my grandma used to give me her phone number and it had letters in it because people would store the letters off the phone. What happens if you got 1-800-Flowers? Do you want to stop and grab your phone and, okay, F is what, 6, L is... No, just type in flowers. So that's why I store it as text. If it's not something I'm going to be doing math on, text. But that's my rule. You can do whatever you want. It's your database. That's the beauty of doing it yourself. They're your Legos. You build whatever you want with them. I just give you my opinions on stuff. Next up, this guy's asking how to use an Access database directly from Google Drive without getting all those errors. The answer is don't. That's actually the whole point of the video that you're commenting on. Google Drive is fine for storing or transferring an Access database, but don't open and run the database directly from the synced folder, whether it's Google Drive, Dropbox, OneDrive, any of those. I've talked about this in a million videos. Now, years ago, I used to do this myself between my home and my office when I used to actually have an office that I'd take 20 minutes to drive to. I'd copy my database, which is a relatively small database file, maybe 50, 60 megs. I'd copy it up to the Google Drive, drive to the office, and then I'd copy it down to my local workstation there, work on it, then copy it back up when I was done. You could save it on the Google Drive, but don't run it from the Google Drive. You're just begging for corruption. When it tries to sync, if that database file is open, it's not going to be pretty. It might work for a while, but it's great until it's not. Right? If it's just you, if it's one person, and you're careful, okay. If you run the database live off the Google Drive, especially with multiple users, you are begging for corruption. If you need simultaneous remote access or multiple users, that's when you want to start looking at SQL Server. Okay? Okay. Next up, we got Simon, who also agrees the postal code should be stored as text, especially since countries like Canada and the UK use letters and numbers. He also mentioned something I didn't know, that Canada apparently has a special postal code for kids writing to Father Christmas. That is awesome. But yeah, that's another great example of why postal codes, zip codes, all that stuff belong in text fields. They're identifiers, not numbers. Once you start dealing with international stuff, you got letters, spaces, leading zeros, and apparently some Christmas magic. All right, next up, we got RTAT1 pushing back on something I said in the BOF and EOF video. He says, record count may not initially give you the correct total number of records, but it should still reliably tell you whether the record set is empty. And he's right. That's a good catch. I should make a distinction here. With a DAO record set, record count equals 0 is a perfectly valid way to determine that you've got an empty record set. The problem with record count is using it as an actual count. You might open a record set containing 500 records and initially get 1 until you move last and force access to visit all of them. So record set greater than 0 is fine for do I have records. I still prefer checking BOF and EOF because that's explicitly what I'm testing. But your method is perfectly valid. So thanks for keeping me honest. It's just a matter of I wouldn't want future me or someone else seeing record count and thinking that it's an actual record count. But if you're just using it for a count, to know if it's 0, then yeah, you could get away with that. In fact, in one of my databases, I actually wrote a has records function that does something similar. So yeah, there's lots of ifs, thans, and buts and other buts, and yeah, but you're right. All right, continuing on with the BOF EOF video. Oso asks why I check both BOF and EOF to see if a record set is empty, since a newly opened record set starts on the first record if there is one. Wouldn't just checking EOF be enough? Or BOF, either one. And yes, you're absolutely right. Immediately after you open a record set, if it has records, access should put you on the first one. So at that moment, just checking EOF or just checking BOF is enough to tell whether the record set is empty. The reason why I always teach BOF and EOF is because I want my students to get in the habit that's safe regardless of whether they've used the record set or where that record set is later. Because once you start navigating through it, EOF by itself or BOF by itself doesn't tell you that the record set has records or not, right? EOF by itself could simply mean you moved past the last record, or BOF could mean that you moved before the first record. But when both BOF and EOF are true, that's the definitive condition that there are no records in that record set. So you're correct. There are shorter ways to do it immediately after opening the record set, if you do it immediately. All right, this is just one of those best practice habits that I teach beginners, because 6 months later, you're going to use the same test on a record set that's already been moved around in, right? And I don't want you wondering what happened. So check both, and you don't have to think about it. Just get in the habit of always checking both if you want to know whether there's records or not. There's a method to my madness. I've been bitten by this stuff before. That's why I try to teach you guys my best practices, at least. So, But yes, good question, and you are correct. Next up, we got Satyaban watching Access Beginner 1 and wondering why when people build SQL statements in VBA, they use ampersands and quotes around form fields or variables instead of just putting the field name directly into SQL. Well, this is really what's called string concatenation, and if you're still on Access Beginner 1, don't worry if this looks like hieroglyphics right now. You really don't even need this yet. Later, when you start building SQL statements in VBA code, the SQL processor can't magically know what a VBA variable or a control on a form contains, so you have to build the string dynamically and then put the actual value into it. And the ampersand is what concatenates or glues those pieces together. Now, another big thing is the employee ID. If that's a number, then you don't need to put quotes around the value. If you're looking for a text value like a last name, then SQL needs the quotes around all that text. And you have to be careful that there aren't double quotes inside the text. That's a whole different level of escaping characters. Dates have their own delimiters too. They use little pound signs. So once you understand concatenation, all those crazy looking ampersands and double quotes start making a lot more sense. Go watch this video on concatenation and watch this video where I cover the single quotes, the double quotes, the double quotes, and all that stuff. So there's lots more to it, but these videos explain it. All right, hey, if you're still with me, hit that like and subscribe button if you haven't already. If you like my videos, it helps more people find my channel, and I'll be forever grateful. Don't forget to stop by my website, check out my What's New. Got all kinds of new stuff. Always posting new videos and templates and updates and random bits of Access goodiness here and there. And don't forget to check out my Captain's Log, where I post all kinds of random weirdness. Like I just added a sticky navbar to my website. It only took 24 years, but I finally have one. What's a sticky navbar, you ask? Well, that's when the navbar up top here stays sticky. Watch when you scroll down. Ooh, I finally joined the late 90s. My website isn't in the early 90s anymore. And the reason why is because I built this whole site with HTML tables. And just to redesign the whole thing would take a lot of work. But I finally got to hide those distracting pennies and I got video. Oh, and I made it so videos you can turn autoplay on and off too. So, you got to be logged in for that. So, yeah, there's lots of cool stuff on my website. I also wrote about the Heisen bug, right? And a bug that doesn't exist until you see it. Oh, someone's beaming in. Hold on. Tribbles. I also wrote about my journey to go see the recent eclipse in Spain and about how I got clouded out. So, that was kind of a bummer. But, yeah, that's all on my Captain's Log. And don't forget to stop by the merch store, pick up a t-shirt, pick up a mouse pad, a coffee mug, get a copy of my book if you haven't already. Stop by the forums if you want to ask questions. Got lots of great moderators and advanced students that love helping people out. If you need more help, if you're looking for a tutor, a developer, someone to work with, check out my Access Developer Network. And make sure you're on my mailing list so that every time I release something new, you get an email. And I won't spam you much. But there you go. That is going to do it for your Tech Help Quick Queries for this week. I hope you learned something. Live long and prosper, my friends. I'll see you next time. If you enjoyed this video, hit that thumbs up button right now and give me a like. Also, be sure to subscribe to my channel, which is completely free, and make sure you click that bell icon and select all to receive notifications whenever I post a new video. If you're new to Microsoft Access, check out my Access Beginner Level 1 course. It's over 4 hours long and it covers all the basics like tables, queries, forms, and reports. It's a great place to start and it's also completely free. Members of my channel get extended cut videos, sample databases, access to my code vault, and full training classes every month. Click the join button for details. Thanks for watching. I'm Richard Rost with AccessLearningZone.com. Live long and prosper, my friends. I'll see you next time.